Can you hear me now? Yes. Okay, cool. So yeah, okay. I changed things are a little bit different because that was really confusing. So let me know if it sounds different or weird or anything, but um hopefully it's fine. Uh, hey, Jappy, I'm glad you're here because we're going to go over some of our syntax we were talking about last night. So, hey everybody. Let me go ping the Discord and then give it a minute or two for people to trickle in and then we'll get started. Um Okay, and then I will start Keycaster. This should go right here. Is audio volume and everything fine, by the way? How about your OS project progress? It's going good. Yesterday we set up the bootloader. We decided not to, for now, write my own. So we pulled in the Mine, and we're using that. But yeah, it's going good. I was gonna do that this morning too, and then I switched because I feel like I need to be focusing on Lovely right now because I don't want to get really far with the OS and then have to rewrite the whole thing in Lovely, you know? So audio's fine. Thank you, Jappy. Is that how you say it? Jappy? JP? Jappy? Yappy? Not sure. Yeah, one more minute here and then we'll start. All right, let's get going. So basically a few things. I want to have a conversation about memory management. Your name has no wrong pronunciations. All is good. Okay, I'll just keep calling you Jappy, I guess, because that's what I've been calling you in my head. I want to talk about memory management and ownership and like what we're gonna do there. Like whether we want to do something more Rust and like more Rust-like and safe, or whether we want it to be, you know, unsafe, but with lots of nice things to help you keep it safe. But we'll talk about that, and then I also want to talk about some syntax that Jappy and I were on a call yesterday, and we talked about a bunch of new stuff. So I just want to like see what you guys think about all that. What will your programming language be like now? C family syntax? It's sort of like C family syntax, I'd say, yeah. So I made a syntax. It's just like a lovely file, syntax.lv. That's in the root of the repo. It's up on GitHub. I have some local changes that are new from the conversation yesterday with Jappy, but I'm going to try to keep this up to date as we like decide on syntax and stuff. So as far as this goes, you can ignore this for now. this is all stuff that people who have been following should be, well, maybe not that, should be familiar with. All right, and then if you remember that we made pretty much every user-defined type, except for this is supposed to have this, right? We changed that, didn't we? Okay, so this is how you define a user-defined type. Okay, this is an enum. Everything's like by default an enum. Or everything really is an enum under the hood, I guess. But so this would be like enum with two cases, bar and baz. Enums can also have attributes. We updated the syntax a little bit, so that's why I'm adding these colons. Enums can also have attributes, which start with an at, which is sort of a nice mnemonic helper, right? Because then you have ats for attributes. And then these are like fields and like structs. So you basically, everything's an enum, but they can have fields. So here's enums with associated values and attributes. So this is just like, you know, associated values in Rust or something, right? So you can open up parens after a variant, and then you can just stick another type in here. So any other type. And they're just, generally they're anonymous. You could stick a name type in there too. You could stick an int in here. You could stick any type in here, right? So, hey Robin, glad to see you on here. Just going over some of the new syntax. Well, some of this isn't very new, but it's about to get new. So, most people should be familiar with this if you've been following. And then as far as instantiating these things go, so like foo up here, right? If I want to make a new bar variant, I'd say foo, so, and then you add a dot to specify which variant, and then you open up squirrelies and you specify the values for the fields, okay? So the fields in this case are just data, so I'm saying I want a bar variant with the data as 8, okay? I also could have said a baz variant with the data as 8, right? So if there's associated values, then you would have parentheses right here, okay? And then you'd fill in the inner thing right there, which is what we're doing down here. So animal, I'm choosing a dog, okay? Dog needs associated values, okay? So I need to fill in that breed is a lab. And I also need to, then I open up the other squirrelies, and this is for the attributes on the animal type. Does that make sense? Let me know in chat, by the way, if any of this like just totally doesn't make sense, or you just have questions about it or anything. That's totally fine. If I had made instead a cat, look, a cat doesn't have any associated values, so I can just leave off that entirely, right? But since dog does have associated values that I need to instantiate, I need to pass this in here. So I'd say breed is, you know, lab. Oops. Did you build this from scratch, or did you fork it from an existing language? It's totally from scratch. Cat cement wants to see a cat. So look, you'd say my other animal would be animal.cat. You don't need to put anything in here because there's no associated values with the cat, but I still need to provide, you know, can bite, which is definitely true. And name, you know, cement. So something like that. I should mention, by the way, that mutability, so we should know that like the colon is for mutable, it's for immutable variables, equal is for mutable variables. If I make this thing mutable, then I can also specify which of these are mutable. So now this is a mutable field on my other animal, right? But this one now is constant. So he can't change his name, but now he can change whether or not he can bite. Okay, does that kind of make sense? So it's exactly the same. So you know how you make variables, like you can go x int, and then down here x equals 7. Now x is mutable, or we can say x is immutable. Either way, same thing if you do it right up here. So you can say x is 7. This is immutable. With an equal, it means it is mutable. So same exact thing. If we use colons down here, this means it is mutable. Sorry, it isn't mutable. And if we use equals, it is mutable. This is giving crystal. Wait, what does that mean? But it's looking good so far. So basically, mutability can exist on a per attribute basis. Is like kind of the concept here, right? So if you make, by the way, if I made this whole thing immutable, it doesn't make sense to have any mutable fields, so these would all be forced to be like that, I think, probably in the type checker. But if I do make this mutable, then I get to choose which of the fields I want to be mutable. And that's again on a pure like instantiation basis. So like my other animal, this one could be that way, but my other, so make this cat1 and this one cat2. So this cat can change whether or not it can bite, but this one can't, right? And so you can just do these things, mix and match. And so this one can change its name, this one can't change its name. This one can't change whether it can bite, this one can, right? So it's on a per instantiation basis. Maybe I'll keep one of those as an example. So I'll say like can bite is mutable, name isn't. All right. Attributes can have default values, right? And they can be inferred or not inferred, right? So this would be like an inferred type. You don't have to specify int, because they can infer that just like anywhere else. And then you can also specify it if you want, right? So these would be default values, right? They can also have constant default values. Joppy did a lot of the work on this, so shout out to him. If you have constant default values, then they can't be changed. They basically just come with it, right? By the way, if you're instantiating, I might show this later, I forget. But if you're instantiating something with default values, if I want to make like a foo, right? Then I don't need to specify things that are default values, right? And I can't if they're constant. So there's that. If no variants are specified, you get one for free called default. This ends up behaving similarly to structs in other languages. Right, so if you want something that looks like a struct, right, because everything's in enum, then you basically just leave off the variants. Like this is where I would have variants, right? I have like 1, 2 or something. If you just leave off all the variants, it actually gives you one for free. It's like the same as doing this. It gives you one variant for free called default. And then it's just like a one variant enum, which is with attributes, which is functionally like a struct, right? So this is basically just a struct. And to construct this, you would, in theory, go bar dot default, and then you would pass along the attributes in here, right? But if there's only one variant, then you can just leave that off, and you go like that, and then it just acts just like a struct. But technically, it's still an enum with one variant. Default attributes don't need to be specified, and you can leave off the default because the only, oh yeah, that's exactly what I said, right? So data was the only one that doesn't have a default value right here, right? This one has default, this one has default, these one have const defaults. Methods, by the way, are just default, oh, it says right here, constant default values, okay? So if you want to make a method, then you just make a constant, right? So this means constant default value, right? And then you just add a function here. You can just do anything. Although function syntax changed a tiny bit from here. We'll talk about that in a second, okay? So some of the syntax isn't all up to date yet. Yeah, so you can leave off .default, and you can also leave off the default attributes. You could, so these two here that are mutable, right? Because they have the equal sign, these ones I could override here with something else, okay? So I could say data default equals, 12, right? Because those are mutable, I can override them. But the ones that are constant defaults, I can't even specify them if I wanted to. So use equals for mutable fields. Yep, if you want to access a method or a access data, this should probably say access attribute. If you want to access an attribute or a method, then you'd index in like my bar dot at, right? So dot at, I could say data, or dot at my method, and then you can call it. So that's how you get into attributes. We had originally talked about the at, but we decided that doesn't look super great. So we're going with the dot at. Get a sip of my tea. It's hot. Okay. You can use, this is what we set up here, up there. We can use mutable and immutable fields in the same instantiation of a type, right? So data here is constant, data default is mutable. All right, and then from here on down, this is going to be not quite as organized, but it's what we just kind of figured out yesterday. Okay, ifs. So ifs look like this. Okay, we have if condition colon expression. Okay, this colon expression thing ends up being a very common pattern in the language. I need some water. Okay. So this can be anything, right? So I could say, for example, if, you know, like x is greater than 8, then, you know, print high or whatever, right? And so this is an if. Okay. I can also, so for those of you who know Rust or will be familiar with block expressions, right? So we're going to have block expressions too, which will just be literally exactly like Rust 1. So I can say something like make x equal 8, y be 7, and then, you know, x plus y, and then don't add a semicolon, so that this is like the kind of the return value of this block expression. And then I could assign this to something like this, right? So y is going to end up being, you know, 8 plus 7, which is what, 15? And does that kind of make sense? The people who know Rust will just know this instantly, right? So my point in saying that is that these expressions can and could be any expression, right? And so it could be a block expression, in which case it ends up looking a lot like a normal if statement, right? And so you can have this be, you know, something like that. And then it looks a lot like a block expression, right? But if you only want one line in here, then you don't have to do that. You can just do this. And because we have this colon here, right, it ends up, that kind of separates the two things. So it looks nicer and it's easier to parse. Or even just possible to parse, because the other way was going to be complicated. Again, please let me know if you have questions or anything. So then we can also do else, right? So you can do expr and then else colon another expr. Okay, that's pretty basic. Else if is actually really interesting. There's not gonna be like an else if. This isn't gonna be a thing really, but you can basically make that by just saying if like x is greater than 7, you know, print high, and then you can add an else branch, right? But then in the else branch you just say else if, and then you get an else if, right? So just like that, because you can stick any expression after the else, right? And ifs are expressions, and so you can just stick an if in there. Else if x is greater than 0, then you can, you know, print lorem, and then else you can, you know, print foo. So this is how you do else ifs. Yeah. So I think that makes a lot of sense. And then, you know, you could do an else if right here. So I said that ifs are expressions. What is the return? What does it evaluate to, right? Well, if you have something like x, if you know, y is greater than 0, then, you know, a 7, else, sorry, I forgot a colon here, high, else, by, right? This, obviously, x would be a string here. So x would be a string, because no matter what happens, right, if x is greater than 0, we're going to get high, otherwise we're going to get by. We're always going to get a string, right? So x becomes a string. If you have an if without an else clause, right? So let me make another one here. Without an else, right? Then if y is greater than 0, we're going to get a string. Otherwise, well, we got nothing, right? And so that's exactly something or nothing. That's the option, right? So you get option string, right? We're also, by the way, for generics, we're not using brackets like a lot of language is. We're going to use parens. Jappy, let me know if I'm messing anything up from what we decided. I think I got it right. But so yeah, ifs without else's just return options, which I think is kind of fun. And again, I'll go through and notate all this and push it back up to GitHub. So there's that. Whiles look, that all looks fine. Awesome. Okay. Whiles look exactly like ifs, right? It's while condition expr, right? Where expr is just going to be execute. Oops. executed as long as condition is true, right? And again, like an if, expert can be a block expression, and likely commonly will, right? And then it'll look a lot just like a normal while thing, okay? Everything's an expression, right? So while is technically an expression, but whiles don't return, so this ends up just being unit. Like if I make x equal to this, that's fine, but just x is going to be unit, which is like void in other languages. So whiles return unit, they don't really return anything. This becomes that, okay. For is a lot like a while, right? If you have something that, we're probably gonna have something like an iterator trait, like in Rust, right? So this could be, you know, an array, or a slice. Those are our kind of two basic list things. So you can say like for item in some like iterator, any iterator type, then do an expression. And again, this can be a block expression, and then it looks like this, which looks familiar to most people probably. All right, loop is a little bit different, right? But it's kind of the same, right? So this just does this infinitely until you break out, okay? All of these are going to support break, right? So if I break out of this, joink, like that, then that would break, you know? But unlike the other ones, loops can return a value, right? So if I make x be a loop, then if this, you know, is a block expression and it does a break somewhere, breaks in loops can have associated values, right? So I haven't really decided on syntax. It'll probably be like that's probably fine. We could do something like that, but then it looks like a function. So probably just that. Like if I break 90 at some point, then x is going to get 90. So loops will have return types that you break out of them with something, but you can also just loop through a bunch of stuff in here. And that's good. That's exactly like Rust too. So. Loop expert. This should probably have a colon here, right? Hello, Lord Pyjo. What do you think, Jappy? Right? Colon here, I think. For consistency, everything else has a colon. Yeah, I think that makes sense. All right, and then a lot of this was just like a discussion about some other syntax things. I just kind of want to build it up from scratch instead of just trying to read through what we eventually arrived at, right? So here's what I'm going to do. So let me just move all this. Why is this not working? Move all this down here. Okay, so that's out of the way. And then we'll just talk a little bit about it. So we changed, so function syntax used to look like this, right? It used to look like fun, and then you have like params, and then you had like return type, and then you have body. Okay, this changed in a few ways. Okay, for one, there's now an arrow here. So we arrow to the return type. There's also now, this thing doesn't require parentheses because we're basically matching the exact same pattern for if. So this is if condition colon expression, colon expression, colon expression, colon expression. We're matching that pattern here, right? This is colon. This can be any expression, right? This expression has to match the return type. So there's that. And then params are still the same. Lord Pyjo, what are you saying there? Lord function name, params expert. Well, we don't include the function name. There's no function name here, right? Because the function name would be something like this. You'd then bind this to a name. And so that's a little bit different. So this is now what functions look like, which just made me have a thought. We don't really need... well, yeah, okay. We'll talk about that later. That's fine. So this is what something would look like. For example, if I made an add function, then it would be like fun. You could do, you know, x, like the tilde means unlabeled. It's an int. Add that to y, which is also an int. This returns an int. And then over here, you'd say, you know, x plus y. So this is a function. Like, there's nothing stopping me from, you know, wrapping this in squirrelies and making it a block expression, but there's no need to. I can just do it like this, right? So then this gets called like add x, or sorry, add, you know, 3, 2, 4. which again reads really nice. This is straight from Swift, the whole labeled arguments thing. But so that's that. And then yeah, so that's pretty much that. If I want to make generics, so generics was a big thing we talked about, right? So if I have something like an identity function, right, which takes a function, it takes any x, which is some type, right, and then it just returns the sum type out of there, right, just by returning x like that. Then this, if you want to mark, like, so, sorry, there's no space there. In some, or there is a space there. In languages, most languages, you'd have something, you know, like you declare a generic right here, and then you pipe that through, right? We decided to just leave this off, right? So you don't have to declare anything. And then for generic types, you kind of do it OCaml style, right? So we'll do like tick A, which in OCaml they call this alpha. So we could say alpha, I guess, but so you have tick A. So this basically declares a generic type, right? So this is, it takes an X, which is some type, and then returns that same sum type, right? So those are generics. What would be the next like good thing to talk about? So then there's, yeah, protocols, probably protocols, right? Yeah. I should just recreate that that list type. So if I had something like so Rust traits Swift protocols, right? Interfaces in some languages, they're kind of like type classes and functional languages sometimes. So we're calling them protocols in this language. Use the proto keyword to define them. Proto. Jappy has to leave soon. No worries. Thanks for stopping by though. So if I want to make a say I have, this is like an example we did yesterday, right? So if we have a type list, which also now has the colon syntax, right, to make it kind of to match our style, right? So if we have a type list, which is an enum with, what is it, like it's either nil, or I guess we call it empty, right? The lists are either empty or they have with, I don't know, what do you even call that? What did we call that yesterday? Oh yeah, cons. I guess that makes sense. Although the cons really, we can call this with, I guess, or non-empty. I don't know. And then this will have an associated value, right? Which will be like head. Or I guess the cons make sense actually. Let's do cons. We'll do, this has two attributes, right? Head, which is a some type, right? So here we need a type, which means we have to make this type generic, right? So I'm gonna do it here. It's generic over tick A, right? So head is that, and the tail is a list, right? So it's recursive. And then the syntax we decided for recursive things, right? I think we had to do, yeah, rec, okay. Wait, what did we do? Oh yeah, and then we have to, okay. So first of all, this needs to be, you smell functional programming? Yep, this is very functional way of making lists, right? This is just an example though. I don't know how, well, we're not gonna really have lists probably as a primitive. We have arrays and slices, but very inspired by OCaml and stuff. Since this is recursive, right, you'll have to mark it with rec because this is just an anonymous type, right, that we're assigning to this right here, right? So if this is an anonymous type, it doesn't know what this list is here, is referring to itself, right? And so this rec keyword basically tells the compiler that this is referring to the type that is being assigned to. Does that kind of make sense? So that's how you make types. Oh wait, do we have a space between that, before that colon? We did. There's a space before this colon. Like that. Okay. So that's what the rect does. Also, this needs to be an owned, like an owned pointer, right? So this would be like a box in Rust or something, but to add a layer of indirection there. So there's that. Okay, so this is how you could define like a list thing, right? And then list could have, for example, a method on it. Let's just do some examples. So this is what we did yesterday. It's like a map method, which is just, again, a constant attribute with a default value, which is a function that takes self, right? So you just can pass self in like that, and then we take a function, right, which would be oh, we didn't talk about, we did talk about function types. No, we didn't talk about function types. So to notate a function type, you do fun and then parens. It's exactly what you'd expect, right? And then you do the type in here. So we could say of a generic in here, like this could go from B, so we're already using A up here, right? So we can go from B to C, right? Some B to C. And then this goes from, this will create a list of C, right? Yeah, that's correct. Okay, and then basically I will, and then did we match? This is where you kind of need a match, right? And so we did talk about match syntax. Did I use a match? I did use a match syntax. So match is pretty basic also. By the way, this whole stream isn't just going to be talking about syntax. I just want to kind of bring you guys up to speed. So I can match, if I match on self, right? So it just kind of looks like Rust match self. There's not a colon there, is there? No, there's no colon there. Maybe there should be colon there. Well, no, because this is an expression. Isn't an expression. It's a little bit different. So no colon there. So you match self. And then you can use leading dot syntax, right? So I don't have to specify, you know, list dot empty and list dot cons. We already know what the type, we already know that self is a list, right? So there's no reason I need to specify that. So you can do leading dot syntax, which for those who know Swift is exactly the same. You can just do that, except for these are uppercase, not lowercase. And then we use colons, right? Because then this is colon expression, just like everything else, right? So the whole colon expression thing is a very common pattern. So that colon kind of takes the place of the fat arrow in Rust, right? So we'll do colon expr. This can be anything, of course. It can be a block expression, then you have that, right? But if we have empty, so if we map an empty, if we map on an empty list, we just get an empty list, right? And then if we map on cons, then what do? We'd make a new list, right? So we construct a new list. Oh, we need to like destructure that, right? So what was the cons? Yeah. Okay. So you can destructure, when you're pattern matching here, you can like get the associated values out of here, right? So you can get the head and the tail, right? Hello, Tez. Was that my daily hi? Can I make a group Discord page? There's a Discord server. Is that what you mean? The link is in the description down there. So now we have head and tail, right? And so then we just need to make a new cons. So we'll make a new cons. What's the best and worst parts of coding? The best part is that, I don't know. And the worst part, I also don't know. It's a good question though. I'd have to think about that. Cons. Oh wait, are these separated with commas? Did we separate them with commas? Yeah, they're separated with commas. Okay. Where was I? Here. That's so comma, right? So we create a new cons thing, right? With the head being f of head, right? So you supply f to that, and then the tail being it'd be tail dot map, right? You just make this recursive, and so then you map with f. Just make sure that matches this down here, right? Tail map f. Yep. So this is how you could do, you know, a map on this kind of thing. Okay, we got some comments. Worst part is coding, and the best part is coding if you love it. Totally, that was a good answer. Kat says, I'm doing an assignment with you in the background and music. I don't know, Russ, so I can't help. No worries. Best part is when it finally compiles after hours of debugging. Worst part is debugging before. Yeah, that's also a good answer. Do you think you'll ever get a degree to help navigate the job market? You talking to me? I do have a degree, not in computer science. I have a degree in applied mathematics. But I'm not using it. I haven't used it since I graduated. The best part is you don't know anything, and the worst part is you don't know anything. Moral, you won't know anything. That's also kind of a good answer, depending on what you mean by that. Yeah, always know that you're never gonna know anything, but that also means that there's an infinite amount of things that you could learn. So that's kind of fun. Now you might have noticed that I could, in theory, take these squirrelies off here and get something, you know, like this, but that might be a little ugly, depending on your definition of ugly. I'd probably prefer to do it this way. I guess employers would consider your degree useful then. My bad. I thought you didn't have a degree. No, it's good. Okay, so that's how you could write something on there, okay? So that still doesn't get us to protocols, okay? So say I make like a protocol, use the proto keyword, right? This is, by the way, protocol, for those who don't know, is the same as a Rust trait. Oops, that's not how you spell trait. So I can make a proto called like iterator for example, iterator. I'll leave that off for now, right? And so you do like this, exactly how you'd expect. Define it. Let me go check the syntax real quick. Proto iterator. Yes. Let me just copy this. That's good. So you can make a programming language. I've made one, but full of brain rots. Oh dear. You're taking a calc course and a linear algebra and analytic geometry next semester. Any good resources you recommend to prep for it? I've heard of Khan Academy. Anything else? Ooh. Well, what are you in college? Are you in like advanced high school math, or what are you? Depends kind of what level you're at, I guess. Is it gonna be? Are you in Calc 1? In what stage are you in right now making programming language? Right now we're talking about a bunch of new syntax, but right now, as soon as I get back to working on it, it's type checking that we're doing right now for like a subset of the language. All right, so this is like what an iterator looks like, right? So this would be like the type that's implementing iterator, right? And so then you can have associated types like this, right? Like an item, and then you can have, comment that out for now. So you can have like methods on here, which this is just the type that if something implements this, it'd have to implement it. Yeah, I'm on a computer science degree, so it'll be calculus 1 and linear algebra and analytic geometry. I never took analytic geometry. I actually somehow got a math degree and I never took a single geometry class, not even in high school. I never took geometry. What's a proto? Yeah, it's a protocol. It's like a Rust trait. See? Shoink. Never seen that keyword before. Yeah. Because this is a new language, right? So we get to decide on the keywords. Protocol, like what Swift would say protocol. That's kind of just long. Proto's nice. So if I wanted to implement this thing, by the way, does this kind of make sense, right? So it takes like a mutable reference. This is for references. So this is star is an owned pointer / reference, right? This is like a borrowed reference, okay? So this would like borrow self, right? Which is of course this type, and then returns an item, right? You could also have a constant. Basically, methods and constants are the only things you could have on here. You could supply a default implementation for functions, for methods, right? So I could, after this equal, make a function here, whatever. That's the default, but you can also leave off the default and then force everybody to implement it. Doing some differential geometry right now, and it's super fun, and it's certainly not the easiest thing. That sounds really interesting. Good resources for calc and linear algebra, though. Wait, do the tics have special meaning? Yeah, they do. 1 second. So calc and linear algebra. Okay, so here's what I did, but I don't know if this is the best way. So, so I just took calc classes in college, right? And so that's like how I learned, was just in college. But prior to that, I read, okay, so when I was like 12 and 13, there's these books. Who knows about Life of Fred? Life of Fred. This guy? It's this guy, Stanley Schmidt, that creates these like math textbooks called Life of Fred, and it basically is like about this guy named Fred who's like 6 years old, and he basically like teaches calculus, and they're like the best books ever. And when I was like young, I just read those just all the time for fun. So that kind of got me sort of like familiar with the concepts of like calculus and like upper math. And then when I actually took classes in college, I think that made me click better. But that's pretty much all the resources I use. It's just college classes and reading those for fun. Highly recommend Life of Fred. It's the best. So like Linux from scratch for babies, but an actual baby wrote it. Yeah, maybe like that. Well, so the idea is like Fred is like this little prodigy kid that ends up getting a job teaching at a college when he's like in diapers. But it's kind of a wacky story, but they're really funny. Okay, so what were we doing? Okay, implementing iterators. How do we do that? Remind myself. Impl iterator array. Okay, doink, doink. Gotcha. Okay, so so here's how we would. So we have this like list type, right? So we will now impl iterator on our list, right? So if we impl iterator, right? So in the place where tick A would go, we're now passing our. Oh yeah, you asked do ticks have a special meaning. Ticks are for generic type parameters. Wait, can you make a video on making an RDBMS from scratch, like a SQL or something? Wait, what's RDBMS? SQL's I know what SQL is, but what's RDBMS? So and where this would go, we're implementing it for now list, right? Of list is generic. So impl iterator list, right? Is that how we do it? Is that how we do it? Impl iterator. Yeah, okay. So then I need to. There's this type item, right? So in here I'll just say type item. You need to say what this is, right? Item is tick A, right? Awesome. Thank you so much, Micaiah. My math is very rusty. High school was 10 years ago. So I definitely need to get familiar with concepts before lectures start. Gotcha. Yeah, I don't know. I don't know that I'd recommend Life of Fred to everybody. It's just kind of like what I did. I was kind of like a nerdy little kid, so I love that stuff. But I'm sure there's other resources out there too. I did do a lot of Khan Academy. You mentioned Khan Academy. I did Khan Academy. I forgot about that. That helped me probably a little bit. Although I didn't do much. I don't think they have a ton of upper math in Khan Academy, but they definitely have calculus. So I think I did some of that. So it's a variable with a generic type or a type itself. It's a type itself. Yeah, tick A is a type. Sorry if that wasn't clear. Right? Because this would be the type that something that is implementing iterator, right? So here we're passing into that list. And then this is a new one here. You can name this whatever you want. This could be tick through, but I'm just using A. That's what OCaml does. Yeah, so to implement this, we need to say, okay, our item in this case is the thing that list is containing, which is tick A. I could do this specifically for, a list of ints, but we want to do it generically, right? So we'll do it over that. I actually want to learn making a database from scratch, so maybe you could help. I've never done that, so I don't know if I could really help. And then I need to make this next thing, right? So we just can define a function, right? It takes self. It takes mut self, right? I don't know. We haven't decided about this syntax yet. Wait, what are we doing on here? Oh, we just did self, right? Okay, so we haven't really decided about this. Like, if you want to specify, I mean, we already know in the type signature that this thing has to be a mutable reference, so maybe we could just leave that off and do that. Or maybe you have to do like this. Like, this is technically what it would be. I don't know. We haven't decided on the syntax yet, but it'll be something like, like Rust would be this. Take self, and we know it has to return an item, right? And so, which is the same as tick A, right? So item, and then we need to implement it, right? And so then in here you do your implementation. Does that kind of make sense? Everybody following protocols? It's just very Rust-like, so that should be pretty straightforward for most people. Need semicolons though. Shoink. So you can make your own types just like making a variable. I feel that I'm missing out a lot. What do you mean exactly? Yeah, you can make your own types. That's kind of like a common thing though, right? It's just like how in Rust you can say like type foo, whatever, or you can say like struct foo. You're making your own type, right? Or enum foo. The syntax in Lovely is just type foo, like this. So it's kind of the same thing. This would be more equivalent to list because we have enums and no structs. Yeah, so there's that. Anybody have any more questions about any of this? Oh, now you get it? Cool. Any questions at all? Y'all feel like this totally makes a lot of sense? So this is pretty cool. It looks a lot like Rust. How do you handle memory? Okay, so that's the next thing we need to talk about is memory. Yeah, so a lot of this looks like Rust, especially this basically looks almost exactly like Rust. Some of the concepts are sort of different though, right? Like how this can be, this is just an expression. How everything, I guess Rust is really expression based too, but this is even more so. And then how we only have enums, that's also sort of unique. But yeah, it's very Rust inspired. Memory is a cause of much grief. So I really want to get that right. So let's talk about that. Memory management. Okay, so I'd love it if you guys could give me lots of input for this because I'm really curious what you guys think. I haven't done a ton of, I haven't really written much in like unsafe low-level languages, like C, C++, Odin, Jai, Zig. All those are like technically unsafe, right? Because you can write unsafe code easily. Whereas Rust is technically safe. Like everything is perfectly safe unless you go into an unsafe block, obviously. It's definitely not going to be garbage collected. It's either going to be, it's going to be some, like we need manual memory management, right? Because we're trying to make an operating system. But it's just whether we try to make this totally safe or unsafe, right? So safe implies, you know, dealing with like ownership, borrow, checker, lifetimes, right? If we did it kind of like Rust does, it's like all this stuff. Unsafe, you know, it's you're doing your own like free and alloc and you know, all this kind of stuff yourself. So what do? Or do we try to find something here? Like, or something here that's like safe but easier. Like this is what Rust does, right? And it's both very awesome and very difficult, right? Difficult to implement and difficult for like the user, right? Like that's why Rust learning curve is so steep. It's pretty much entirely because of the whole ownership model, right? Because the borrow checker and lifetimes and all that kind of stuff is kind of hard. Whereas this is a lot simpler, but it just basically means you can write unsafe code. But you can make that easier with stuff like defer, you know? And so inventing a safe memory system like Rust sounds like a 10-year challenge. Maybe an easier unsafe. Well, I don't mind the whole time frame thing, right? It doesn't have to be... I don't want to make any decisions based on just how hard it's going to be to implement. Is kind of my philosophy, right? Like if it's going to be really hard, it's going to be really hard and we'll just work on it for a long time. That's fine. I don't have like a deadline for this project. So I don't feel like this would be like, I definitely want to be 10-year, right? I don't think this would be like super duper difficult. This would definitely be a lot easier though. Not with that attitude? What do you mean, Robin? What do you mean, Robin? Crazy Nunchucks, have you ever checked out humbleOS? Yeah. A simplified ownership model would probably be best. Less problems for the compiler and less problems for the user. Yeah, could we make it simplified and safe though? Or not? There are a lot of unsafe memory managements. Wait, not doing something because it sounds too hard? With that attitude, you better give up. Oh yeah, I get what you're saying. Yeah, exactly. This whole project is already kind of gigantic, and so like making it a little bit more gigantic doesn't scare me a lot. Like the whole thing's already like really scary. So if that makes sense. Yeah, it was more a response to that guy. Gotcha. Hello, Hyperbanner. Okay, like how low level learning has once built one. I haven't seen that. Simplified would be less safe, probably. Yeah, that's kind of what I thought. I feel like maybe a system that only mitigates 80% of memory stuff, like use after free and leaks, but still gives the user more leeway than Rust does. I don't think C like management is a good idea though. Yeah, I don't think so either. So you're saying something that falls kind of like here-ish or here-ish? As opposed to down here. Well, I'd put defer like here, you know. You maybe look at what Serenity OS did. You mean like with Yacht, their language, or what they did with C++? What are you referring to? Because wasn't Yacht going to be a memory safe language? And are they even using Yacht? Because I know he did put a lot of work into it. I don't know if he actually incorporated it into the operating system. Yacht. Like, is this even being developed? Yacht. It was a little bit like a year ago, but not much recently. I guess there was a commit 2 weeks ago. Goals memory safety. So they did try to make it memory safe. Memory safety. The following strategies are employed to achieve memory. Oh, this is great. Okay, so it's automatically reference counted. So that's a little bit different. Strong typing, bounds checking, no raw pointers in safe mode. Well, this is another option. We could just do arc. But then we need some way to drop down into like manual memory management though, right? And so this kind of doesn't do that, right? It's kind of higher level. There's 3 pointer types. T, a strong pointer to a reference counted class T. Weak pointer to reference count becomes empty on pointee destruction, and then raw pointer. Null pointers are not possible in safe mode, but pointers can be wrapped in optional. Oh, they do this question mark for short. I kind of like that actually. This actually looks like an intriguing language. Doesn't it transpile to C++ though? Oh yeah, it currently transpiles to C++. I feel like Serenity OS really slowed down when Andreas kind of left to go work on Ladybird. It's kind of sad. Look at this. Joink. I mean, don't get me wrong, Ladybird's really awesome, but Serenity was so cool. If you guys ever like ran it locally, it's like the coolest thing ever to play with. All right. By the way, how do you plan on making the code run once you get there? What do you mean by that? What are your opinions about a program that examines itself and integrates its updates within the main body of the program to reduce bloating? Wait. A program that examines itself and integrates its updates within the main body of the program to reduce bloating? Could you explain a little bit maybe? I'm not sure I understand. Compiled or interpreted? Oh. It's going to be compiled. Yep, compiled to NASM. All right, well, people, we need to decide on something here. So, no, not JIT compiled, just ahead of time compiled. So, let's just start thinking about some of the problems, okay? So what are the problems? Let's think about, like, why is Rust doing what it does, right? And then what are some alternatives? So basically, this stuff like makes my brain go for loops. If you have a variable called x, which is like, say it's a string, or say it's like a, say we don't have a vector, we have an array type. So say it's like an array. I don't know how we'll instantiate arrays, but say it was like, you know, array. Or maybe we should just use, let's just use Rust syntax for a second. Okay, so pretend this is Rust. If we have something like, or we could just open up a Rust file, that'd be easier, no? Main. Okay. So if I have something simple, bow check, defers and things, bridging over safe and unsafe. It simply gets complicated as you add updates. Number of parts that interact with each other grows magnitude, producing bloating. Yes, but what's your proposed solution to that? I'm not sure that I understand that. All right, so if we have something like let x equal, you know, vec. That's like 1, 2, 3. You know, something like that. So there's x. How could I get a borrow checker error out of this, right? If I have something that consumes x, like function, you know, print vec, that takes a vec of usize and print maybe just like print line p, right? So something like that, and then I go to like print vec x, right? So this sort of like consumed x. If I try to use x down here, it's fine. Wait. Guys. Wait. Hold on. I need to think about Rust again. Try compiling it? Yeah, why is Rust not rusting? I can't exactly compile it because the checker has type errors. There we go. Okay, there we go. Okay, so this is fine. If I try to, oh wait. Yeah, I thought that was funny too. Okay, there we go. So now if I try to use X down here, it's because I had errors over in the checker. That's why. So if I try to, yeah, if I use X after, okay, well I'd have to do something like this. Y equal X, right? Use of mood value. Because X moved into the scope of this function, right? All right. So what makes this unsafe? Can somebody give like a one-line explanation of what makes this unsafe? Because X could be freed in print vec, yeah. Or is it always freed in print vec? If vec used arc, it would not be unsafe. Yes. Wait, so how does this actually work? Yeah, it's always freed in print vec, right? Because as soon, so it enters into this scope, X now lives in here, and then as soon as it goes out of scope right here, it's freed, right? And so after this, it's freed. Is that correct? X was freed. Yeah, because of the drop-in pull. So this makes sense. Now, if instead we borrowed it, then we're fine, right? Because you borrow it, you do the thing, and then instead of, so you're not consuming it anymore. You're just looking at it for a little bit, and then as soon as you're done, when you got a when you got a scope, instead of freeing it, you like give it back, basically the scope, right? So then X is fine. We have X back. So that's what a reference is, right? It just says you're borrowing it instead of owning it. So that just makes a lot of sense to me. But maybe it's because I'm used to Rust. Sorry, okay. So, like, what's an alternative? Is there even like a reasonable alternative to this that's safe? What does Mojo do? I saw something about Mojo recently. Mojo. Oops. Mojo memory management. Intro to value. So they use like an ownership model too. Okay, because memory is limited, it's important the programs, okay, yeah. Remove unused data from the heap. Free the memory as quickly as possible. Figuring out when to free that memory is pretty complicated. Yep. Some programming languages try to hide the complexities of memory management from you by utilizing a garbage collector process. Yep. Significant benefit of this method is it relieves developers from the burden of manual memory management, generally avoiding more errors and making developers more productive. Yep. Decreases performance costs because garbage collectors interrupts the program's execution and it might not reclaim memory very quickly. Yep. Other languages require that you manually free data that's allocated on the heap. When done properly, this makes programs execute quickly because there's no processing time consumed by a garbage collector. So this is stuff like C and C++ and Odin and Jai and Zig and all that kind of stuff. However, the challenge with this approach is that programmers make mistakes, especially when multiple parts of the program really need to access the same memory. It becomes difficult to know which part of the program owns the data and must deallocate it. Programmers might accidentally deallocate the data before the program is done. Yep, exactly. Uses after free errors. They might deallocate it twice, double free errors. They might even deallocate it. They might never deallocate memory leaks, right? So there's kind of three. I'm going to take notes. This is important stuff. Take notes, folks. Notes. Oh, wait. How do we do comments in Rust? Notes. Without ARC, GC or manual management is the only way you think. You personally love juggling raw pointers. Well, you gotta be a good juggler though. So notes. MMM pitfalls are these three things that I listed here, right? So these are the things we need to avoid. Use after free. Use after free. Here, let's do it like this. Use after free. There's also double free. Leaked memory, which means never free. Okay. So if we can find some system that makes it impossible to do all three of these things, then we have a safe language. Is that correct? Can somebody confirm that? We just need a way to make this impossible, and this impossible, and then you have a safe language. And GC just kind of manages all this for you. ARC also manages all this for you. ownership makes you have to kind of jump through hoops to never do this, right? And then like C style makes you do all this yourself. Rust allows memory leaks sometimes when an RC loop or M forget or box leak. Okay, got you. But that's like generally speaking. I mean, it doesn't. This is a good article though. Mojo uses a third approach called ownership, which is also what Rust uses, right? It relies on a collection of rules that programmers must follow when passing values. This is probably the most appealing to me of all of those, right? The rules ensure that there is only one owner for a given value at a time. When a value's lifetime ends, Mojo calls its destructor. This sounds a lot like Rust, which is responsible for deallocating any heap memory that needs to be deallocated. This way, Mojo helps ensure memory is free, but it does so in a way that's deterministic and safe from errors such as use after free, double free, and memory leaks. Plus, it does so with a very low performance overhead. Great. Value ownership models provides an excellent balance of programming productivity and strong memory safety. It only requires that you learn some new syntax and a few rules about how to share access to memory within your program. Before explaining the rules and the syntax for Mojo's value ownership model, you first need to understand value semantics. Mojo doesn't enforce value or reference semantics, supports them both, and allows each type to define how it is copied, created, or moved. Gotcha. So this is like in Rust, you have copy types, and you can clone things, and we'll probably have something similar, maybe. So you're building your own type, you implement it, support value. Okay, so this is just like Rust. You can choose whether it's copy or not. Value semantics looks like Python. Python with types. That's as fast as Rust. It's kind of crazy. SIMD. Oh dear. Okay. So here's ownership. So let's read about this. Like, what do they do? Because I know that I heard somebody say that they did something like their entire motivation for building. I thought this guy was saying he thought their motivation was to make like a Python that's better and faster and cooler or whatever. But their actual motivation was to make like a Rust that is better. And then they needed syntax and they chose Python. So it kind of went backwards. A challenge you might face when using some programming languages is that you must manually allocate and deallocate memory. When multiple parts of your program need access to the same memory, it becomes difficult to keep track of who owns the value and determine when it is the right time to deallocate it. If you make a mistake, it can result in a use after free error, a double free, or a leaked memory error. Any one of which can be catastrophic. Yep. Mojo helps avoid these errors by ensuring there's only one variable that owns each value at a time. Okay. While still allowing you to share references with other functions. When the lifespan of the owner ends, Mojo destroys a value. So that's us freeing a value, right? So far, this sounds like Rust. Okay, sorry. Programmers are still responsible for making sure any type that allocates resources, including memory, also deallocates these resources in its destructor. Oh. Wait, so you still have to manually free things? What does this mean? Any type that deallocates resources is also deallocates resources. Ownership system ensures that destructors are called promptly. Wait. So you're in charge of making the destructor, but Mojo makes sure that it calls the destructor? How does this work? On this page, we'll explain the rules that govern this ownership model and explain and how to specify different argument conventions and define how values are passed into functions. Okay. Ownership summary. Memory leaks are bad if they become big enough for OOM or OOM killer. Otherwise, they are mostly fine. What's OOM or OOM killer? Fundamental rules that make Mojo's ownership model work are the following. Every value has only one owner at a time. So this seems like it makes sense. When the lifetime of the owner ends, Mojo destroys the value. Oh, out of memory. Okay, gotcha. That makes sense too. If there are existing references to a value, Mojo extends the lifetime of the owner. Whoa, wait. This is a little bit different, isn't it? Okay, a variable owns its value. A struct owns its fields. A reference allows you to access a value owned by another variable. So that's just like Rust. A reference can have either mutable access or immutable access to that value. Gotcha. Modular references are created when you call a function. Function arguments can be passed as mutable or immutable references. A function can also return a reference instead of returning a value. Okay. Okay. Argument conventions. In all programming languages, code quality and performance is heavily dependent upon how functions treat argument values. That is, whether a value received by a function is a unique value or a reference, or whether it's mutable or immutable, has a series of consequences that define the readability, performance, and safety of the language. In Mojo, we want to provide full value semantics by default, which provide consistent and predictable behavior. As a systems programming language, we also need to offer full control over memory optimizations, which generally require reference semantics. The trick is to introduce reference semantics in a way that ensure all code is memory safe by tracking the lifetime of every value and destroying each one at the right time. All of this is made possible in Mojo through the use of argument conventions that ensure every value has only one owner at a time. An argument convention specifies whether an argument is mutable or immutable, and whether the function owns the value. Each convention is defined by a keyword at the beginning of an argument declaration. Weird. Argument and whether, okay, each convention is defined by keyword at the beginning of the argument. Okay, so read means the function receives an immutable reference. That's kind of nice. You can only read it. This means the function can read the original value. It is not a copy, but it cannot mutate. Right. Function is defined with def tree. Okay, so read. So far, I am liking how Mojo is doing this, but it's also very similar to Rust. Mut, the function receives a mutable reference. This means the function can read and mutate the original value. It is not a copy. Owned, the function takes ownership of a value. This means the function has exclusive ownership of the argument. Okay, the caller might choose to transfer ownership of an existing value to this function, but that's not always what happens. The callee might receive a newly created value or a copy of an existing value. This is... So far, I really like this system. Ref. The function gets a reference with this is a typo. With a parametric mutability. That is, the reference can be either mutable or immutable. You can think of ref arguments as a generalization of the read and mut. Ref arguments are an advanced topic and they're described in more detail. Okay, I don't get what ref does. It's like, I get what read and mut, and I guess ref is like the general. And then out, a special convention used for the self argument in constructors and for named results. What are named results? An out argument is uninitialized at the beginning of the function and must be initialized before the function returns. Oh. Although out arguments show up in the argument list, they're never passed in by the caller. That seems really good. Rasawe? Is that how you say that? Well, you're some person, right? So you agree? Yeah, Rust does all three of these, right? This is like a read is like the little ampersand, like normal reference. Mut is like the ampersand mut. Owned is just like without that. Ref, I don't understand yet. Out is like what it kind of does implicitly when you pass a self. But what is a named result? Okay, that seems like, we won't worry about that yet. I want to see an example of how out is used. This function has one argument that's a mutable reference and one that's immutable. I feel like I really like this syntax. You've already seen some function that don't declare convention. By default, all arguments are read. Oh, okay. In the following section, we'll explain each of these arguments. All right, so these are borrowed arguments. So this is like mutable references. No, this is like immutable references in Rust, right? Read. The read convention is the default for all arguments, but as is described in def and comparison functions, treat read arguments somewhat differently depending on whether the function is defined with def or fun. Okay, this is different. This is like specific. All right, compare. This is what I want. Mojo's read arguments convention is similar in some ways to passing an argument by const and in C++. Okay, I'm not familiar with that, which also avoids the copy. Major difference between Rust and Mojo is that Mojo does not require a, what in the world does this word even mean? On the caller side to pass by immutable reference. Also, Mojo is more efficient. Oh, does this just mean like a symbol? Symbol, yeah, symbol or design that holds magical power or significance. So basically, if you're passing to a function that already says it's read, right, then you don't have to pass like print that. You don't have to specify v because it already knows it passes as read, so you don't have to do that. I kind of like that. That's pretty good. Exactly, yeah, what you said there. So function like ampersand mut var versus just function bar. I like that. Crazy Nunchucks found the technical name. What he was talking about? Layered architectural decay. That sounds very complicated. Okay. Also, Mojo is more efficient when passing small values, and Rust defaults to moving values instead of passing them around by borrow. These policies and syntax decisions allow Mojo to provide an easier to use program model. I really like this. I think we might do something very similar to what Mojo does, guys. Anybody not like this, what we're reading here? I'm curious. Mutable arguments. I'm building a programming language in Rust while learning both Rust and compiler design through Alex Eichen's course. I've never heard of Alex Eichen. That sounds cool. The course theory is clear, but I'm struggling to apply it in code. I'm stuck and unsure how to move forward. If you'd like your function to receive a mutable reference, add the mut keyword in front of the argument name. If you can think of mut like this. It means any change to the value inside the function are visible outside the function. Yep. For example, this mutate function updates the original list value. Yep. Okay. Okay. Although the code using mut isn't that much shorter, it's more memory efficient because it does not make a copy of the value. Yep. However, remember that the value passed as mut must already be mutable. For example, if you try to make a read value and pass it to another function as mut, you'll get a compiler error because Mojo can't form a mutable reference from an immutable reference. That makes a lot of sense. Have you worked on compiler design before? How did you learn it in practice? What helped you move from theory to actual code? This is my first time, and this is what is helping me move from theory to actual code. I'm literally just trying to do it, but this is the first time I've never done it before. So that's what I'd say. It's just like doing things is what really helps me like go from theory to code, I guess. Maybe that seems obvious. Like actually writing code is what gets me to code, but like I read the Rust book, and I felt like I didn't really know Rust, but I kind of understood the concepts. And so then I just did some projects and yeah, and then I felt like I kind of understood it a little bit better. And I'm still growing a lot for sure. Mojo enforces argument exclusivity. What is this? For mutable references. This means that if a function receives a mutable reference to a value, such as a mut argument, it can't receive any other references to the same value, mutable or immutable. That makes sense. That is, a mutable reference can't have any other references that alias it. For example, consider the following code, because that would be really messy. Right? Because then you could like excuse me, mutate the one and then mutate the other. Yeah, okay, this is cool. The code is confusing because the user might, yeah, okay. One way to avoid this issue when you need a mutable and an immutable reference or need to pass the same value to two arguments is to make a copy. Oh, so you copy it. Okay. Note that argument exclusivity isn't enforced for register passable trivial types like int and bool because they are always passed by copy. That makes sense. Passing the same value into two int arguments, the callee will receive two copies of the value. All right, so here's what I'm thinking. Okay, Mojo style. Okay, is like this. Arguments can be. They can be read, they can be mutt, and they can be owned. Shoink. And that would go like right in the, how does that look syntactically? Like where's the function? So this would be like using Mojo's thing, self would be out. I haven't decided about self yet. But like for example, f. Oh dear, this would be a ref. Or like a, yeah, a read, right? That looks nice. I could definitely get on board with that. Maybe write instead of mutt. It's kind of long, isn't it? I mean, owned is already that long, I guess. I feel like mutt's a little bit nicer. I'd slightly prefer mutt, but pointers, like function pointers, should be ownable and copyable, right? Yeah, I think so. I don't know. Then how are you able to understand everything and actually convert it into code? A lecture isn't something someone would just understand out of nowhere, right? Well, I read a book or two about lectures and parsers and stuff. So own instead of read. Yeah, for that function guy, you're right. It should be owned. You just now noticed my webcam. That's funny. Yeah, it's kind of small. Sorry. Yeah, yet another programmer. I'd say just try to start building stuff and just like look stuff up as you go and like read documentation, and that's just kind of what's helped me. But I know people learn different ways. I just have a hard time learning something without actually doing it, you know? Oh, it's helpful. There's books out there that are like actually doing a project, and it'll kind of help you and like give you assignments and stuff. Those are good too. All right, transfer arguments. And finally, if you'd like your function to receive value ownership, use the own keyword. The convention is often combined with the use of the postfixed that thing on the variable that is passed into the function which ends the lifetime. Oh, that ends the lifetime. Technically, the own keyword does not guarantee that the received value is the original value. It guarantees only that the function gets unique ownership of a value. This happens in one of three ways. The caller passes the argument with that thing, which ends the lifetime of that variable, and ownership is transferred into the function. Oh, I really like this. The caller does not use that, in which case Mojo copies the value. If the value isn't copyable, this is a compile time error. The caller passes in a newly created owned value, such as a value returned from a function. In this case, no variable owns the value, and it can be transferred directly to the callee. I really, really, really like this. Does anybody else feel the same way? This seems like super good. So you explicitly terminate a lifetime. Otherwise, it's copied in if it's copyable. This can be ends lifetime or without copies if copy, or I'm going to move this whole thing over to discussion. Shoink. We don't need that. Then it copies it if it's copyable. How do you guys feel about this whole system with this thing? I feel like I really like it. I don't know about the syntax, but we can always change that. Or like immediate value, like a newly created own value. Like a literal or function call, etc. That's really nice. Anybody think that's not really nice? Following code works by making a copy of the string. Okay. Or if you add that, yep. Regardless of how it receives the value, when the function declares an argument as owned, it can be certain that it has unique mutable access to that value. Because the value is owned, the value is destroyed when the function exits, unless the function transfers the value elsewhere. For example, in the following example, add to list takes a string and appends it to the list. Ownership of the string is transferred to the list, so it's not destroyed when the function exits. On the other hand, consume string doesn't transfer its own value out, so the value is destroyed at the end of the function. Wait. Gotcha. So Mojo destroys S right here because it goes out of scope. But name was already destroyed right here. And so Mojo doesn't have to do anything. That's kind of nuts. Oops. In Mojo, you shouldn't conflate owner transfer with move operation. These are not strictly the same thing. Multiple ways that Mojo can transfer ownership of value. If a type implements the move constructor, okay, we don't have def and fn read versus owned and def. Okay, that's fine. Fascinating. And then there's lifetimes, origins, and references. We could look into this too. This might be good. Lifetimes, origin, references. Hey, IC, what's up? Mojo compiler includes a lifetime checker, a compiler passed that analyzes data flow through your program. It identifies when variables are valid and inserts destructor calls when a variable's lifetime ends. Oh dear. The Mojo compiler uses a special value called an origin to track the lifetime of variables and the validity of references. Specifically, an origin answers two questions. Rewriting your kernel, how about you? I'm reading Mojo documentation to figure out some strategies on memory management and ownership models. And so far, I really actually like it. I don't know if you've ever looked into Mojo. But if you're curious, I'd read these 4 articles because they're super interesting. It's rather similar to Rust, right? It's totally safe, but it's a little more clean, but also explicit at the same time. Ooh. You've heard of it, but never really looked into it. Yeah, I mean, seeing as Chris Latner is the guy behind it, it kind of makes me feel like he probably knows what he's doing at this point. So, seems like he does. Consider the following code. Okay. The line name equals string Joan declares a variable. Oh wait, sorry, I missed something. Mojo compiler uses special value. Oh, we got that. An origin answers two questions. What variable owns this value, and can the value be mutated using this reference? Gotcha. You like the owned thing? Yeah, the owned thing is nice. Consider the following code. There's that. Print string takes a string, you print it. You pass it to here. Okay. The line name equals string Joan declares a variable with an identifier name and logical storage space for a string value. When you pass name to a print stir function, the function gets an immutable reference to the value. Yep. So both name and s refer to the same logical storage space and have associative origin values that lets the Mojo compiler reason about them. Yeah. Gotta look more into Mojo. This is kind of my first time really digging into it, but I've definitely had it on my radar. I can't say I love like Python-y syntax, but it's got some nice. It's like Rust and Python had a baby. Most of the time, origins are handled automatically by the compiler. However, in some cases, you'll need to interact with origins directly when working with references, specifically ref arguments and ref return values. What are you talking about, crazy nunchucks? Okay, working with origins. Mojo's origin values are unlike most other values in the language. You see a bit of Swift in there too? Yeah. Yeah. Some Latin influence. Okay, Mojo's origin values are unlike most other values in the language because they're primitive values, not Mojo structs. Likewise, because these values are mostly created by the compiler, you can't just create your own origin value. You usually need to derive an origin from an existing value. Origin types. That's interesting. So I'll probably have to do something like this, but I don't need to do it exactly like they do. Static origins, derived origins, example, blah, 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 blah. Inferred origins. Oh, and here it talks about ref. Ref seems complicated. We're not going to do ref for now. We'll just go with read, mutt, and owned. All right, chat, how do you guys feel about this system? It would be probably a little bit hard to implement, right? But it's very similar to Rust. But I really like this thing that like kills a value. Any thoughts from anybody? You think it's good? You think it's bad? You think it's fine? So what kind of allocator system? And what about lifetimes? I don't get the read and mutt thingy. Why not just have and mutt? It's literally the same thing as that. But just the syntax. If you have a function that's like fun foo, or in my syntax I guess it's like this. Like x int or x, foo and y bar. Whatever. Then instead of, if like this, everything by default becomes mutt, or not mutt, sorry, everything by default is like that in Rust, or you can specify it by saying read, like it's a read-only reference, right? So I can say that, so read y, or if I want mutable ones, I say mutt, and then it's a mutable reference. Or if I want it to be an owned value, then I do owned. And so those are the three options, and it's just a little cleaner. Like in Rust, it's like this, or like this, right? As opposed to just owned, read, or mutt, right? Which I feel like is a little cleaner. And if you leave it off by default, it's read. How about that? I'd say remove read and make that default. It is the default. But yeah, just make it value into keyword, you mean? That might be good. That could be good. Although I do kind of like the explicitness of it. So the only thing is that our syntax kind of has this idea of like mutable attributes, which kind of complicates things. Like I could make an animal that's, these are all mutable, but this one isn't mutable, which kind of breaks things a little bit, I feel like. Syntax is hard. But I'm pretty sure I want to do something like this. I'm just trying to think. Yeah. All right. Well, I'll be thinking about this. If you guys have input or thoughts, please let me know in Discord. Until then, yeah, I'll be thinking about this. I'll let you know like what I end up deciding. But I'd love to hear you guys' input. But I'll stop the stream here. And yeah, until next time. Probably won't do another stream today. I've got some other stuff to get to. But you think the C# approach then of calling it read only instead of just read? That's really long. Read only. But yeah, I get what you're saying. All right, but anyway, so streams, I'll stop the stream. See you guys. Thank you.